Okay, everybody, we're on page 508, and I think we already know how to do this, but let's go over this again, okay? So if I take a look at this graph, it is the absolute value of x, but it can be done as a piecewise function because there are two different equations, two different straight lines, okay? So the two lines, it does connect, it makes two lines. The two lines are y equals a 1 over 1x plus 0, or basically y equals x. And the other line is y equals down 1 over 1, down 1 over 1x plus 0, or just a y equals a negative x. Okay, same thing, but without all the extra numbers. Okay, so we can write that as a piecewise graph. Remember, y and f(x) are the same thing. So writing y, we'll write just f of x equals x, right? But then they are both connected right here at, x equals 0. So the first graph, line 1, is greater than or equal to 0, and the second graph is less than 0. I can't have equal on both because I can't count the 2 points twice. Now what we find is they do have symmetry of the y-axis, and that is where they're connected. That's where my boundary, I like to call my boundary lines, okay? That's where my boundary line is where they're connected, or where they have symmetry, okay? So then we took a look at another example, okay? If I have y equals x plus 50, it turns out that it's really this entire line here, okay? But I don't want all of this line. I only want the part that's between negative 50 and 0. So erase all that, okay? Second graph starts at 50 and it's down 1 over 1, so that's the second graph, but I don't want all of that graph. I only want the graph between 0 and 50, so erase that. So it does make an absolute value graph, okay? We know it's an absolute value graph. It has the shape of the V, so it's just going to be the f of x, or in this case, I guess it's g of x, equals the negative absolute value of x plus 50, okay? All right, so then on the other page, we just looked at some graphs, and we tried to figure out how we can make them into piecewise. Well, first graph has a slope up 4 over 1, up 4 over 1, starts at 0. And this graph is over here. They're connected at 0, so greater than or equal to 0, because it goes over this direction. Second graph goes down 4 over 1, down 4 over 1, right? There's that graph. So negative 4 of x plus 0, but we don't need the 0. And, of course, it's the back half. It's where x is less than 0, okay? All right. Then we looked at this third graph, and it looks like the slope is up 2 over 3, up 2 over 3, so it's up 2 over 3x, y-intercept of 2. And again, it's connected at 0, but it's greater than or equal to 0 because this graph is here. Second graph, line 2 goes down 2 over 3, down 2 over 3, so we have the down 2 over 3, down 2 over 3 plus 2. But this graph is back here at x is less than 0, okay? Third graph, it's a little bit hard to tell, but it looks to me like it is an up 1 over 1, up 1 over 1. I thought it was up 2 over 1. You know, I thought it was up 2 over 1. I think it's a 2. I think it's a 2 over 1. I think the book's wrong here. I think it's down. So I think this is down 2 over 1. Yeah, like you can see it down 2 over 1, down 2 over 1, right? X minus 3. It would have been 3 if you'd kept drawing it all the way down. It would have crossed at 3. But, of course, we erased that. This graph up 2 over 1, up 2 over 1, right? But they're connected. They're connected right here. See where they're connected? They're connected together at negative 3. And that's where they start. X is less than negative 3 and x is greater than negative 3. Okay, that's all I had. The assignment was page 511 and 512. It has to do with a pool that leaks. Okay, so that's all I have, and I'll see you tomorrow.